Alright, ladies and gentlemen, we're going to start with part one of how to solve systems of equations using row operations with matrices. So this is kind of a big lesson. I spent 2 days on it, and let's go over some of this background knowledge which you'll need. So first things first. So there's some special matrices that are out there. And one of them is called an identity matrix. So an identity matrix has ones down the main diagonal, and then every other cell in there has zeros. So this is a 2 by 2 identity matrix, and then here's your 3 by 3 identity matrix. It's all ones there, and then everything else is a zero. You need to know what an identity matrix is. And the neat thing about an identity matrix is if you times by an identity matrix, nothing happens. It stays the same. So that's kind of an important thing. It's kind of like 1. If you times by 1, nothing happens. If you times by an identity matrix, nothing happens. And there's these things called augmented matrices. So augmented matrices are made from systems. So if you have a system like this, and you take out all the variables, the equals, the plus, and you just write down all the coefficients in a box, it becomes an augmented matrix. So this system would turn into this matrix. You don't necessarily need to have that line there, but depending on who's doing it, they have a line there. If I were to take this bottom system and convert it to a augmented matrix, I would write out 3, -2, 14. That's just the first row, no variables, no equals, no plus. And then my second row here, I'm writing just all the coefficients down. There's 1x, 3y, and 1. And that would be the augmented matrix. So now you got identity matrices, which are just diagonal of 1s and everything else is zeros. And you got augmented matrices, which are made from converting a system into a matrix. And then there's row operations. So, a row operation is when you have a matrix and you change your matrix doing one of these 3 things. You can switch the rows. So let's say I had my starting matrix here. It's just 1, 2, 3, 4, 6. If I wanted to do a switch rows, I could put row 2 up here and row 1 down here, and it becomes 4, 5, 6, 1, 2, 3. So that's one of your row operations. Just switch the order there. And another one is to multiply a row by something. Let's say I want my first row to be 5 times as big. So I'm going to do row 1 times 5. And I can leave row 2 the same. I guess I could times that one by 3 if I really wanted to. Or you can just leave it. If you times the first one by 5, you get 5, 10, 15. And my second row I'm just going to keep it the same for now. That's a row operation. You can times a row by a number. And then our last option is to add rows. And I'm going to add in there subtract rows. You can add or subtract rows. So say I want to do row 1 minus row 2, and then just keep row 2 the same. I'm going to take these numbers and subtract these numbers from them. So it's going to be 1 minus 4, which is going to be -3. 2 minus 5, which is -3, and then 3 minus 6, which is -3. And then my bottom row is be 4, 5, and 6. So those are the row operations. You can switch rows, you can multiply a row by a number, or you can add or subtract rows from each other. Well, if we hop over to your actual assignment, the first 4 problems are you identifying what row operations happened. And so I'm going to come here. Let's say you're starting with this augmented matrix and you're supposed to end up at 2. Well, take a look at what those numbers are and look at the resulting ones and see what's different. Well, I noticed that the second row has not changed. So something changed about my row 1. Did my row 1 get times by a number? Doesn't look like it. Did it get switched with my bottom row? No. So our last option is it got added or subtracted from the other row, and we just added the second row on top. So it's 15 plus 4, 11 plus -3, and then 36 plus -26 gives you the 10 there. So that's what happened there. And then looking from here to here, again, our second row is the same, but our first row has changed a little bit. We went from 15 to 5, 11 to 11 thirds, 36 to 12. Well, that was just dividing by a number, so it's divide by 3. But you may have wondered, well, I thought you could only multiply a row by a number. Well, you have to remember that dividing by 3 is the same thing, or equivalent to timesing by 1/3. And so when I look here and I write divide by 3, what it really means is I times by 1/3. And that's a perfectly legal move to have. I'm okay if you just put /3 because it's divide by 3 times by 1/3. So if you haven't done so, take a moment to figure out how it went from between here and here. Go ahead and pause the video, see if you can figure it out. Alright, did you have any problem with number 1? On the first one, the first row stays the same, but the second row got times by 3. And then number 3 here is actually a challenging one because it's 2 row operations happening at once. The first row stays the same, but the second row got the first row added to it twice. Or you times the first row by 2 and then add it to the second row. If your first row was twice as much, it'd be 30, 22, and then 72. And if you add all those to the second row, you'll get this bottom row here. So that one's pretty tricky. I would say that's a pro level kind of move there. And so if you want to add that to your notes, you can do like the pro step, which would be add or subtract a multiple of one of a row from another. Yeah, that one's really fancy. When you get good at doing these row operations, you'll get to a point where you can do that. You can see opportunities for it, but you may want to hold off for now. So now we've done that, I'm actually going to end the video. I'm going to move on to a part 2 where we actually solve a system.